All right, so let's look at taking the derivative of this function from part A, exercise 9. This is section 2.6. So we're going to rely on, in part, what we know about inverse functions to handle this derivative. What I'm going to do is just treat this in terms of x and y. So y equals natural log of 2 arctangent x plus 3 arcsine x plus 5. So I'm going to try to do some cleanup here to basically deal with I don't know. Hopefully we can get to a point where I can do some implicit differentiation. And to get there, I would like to, move some parts around. So first thing I'm going to do is this. I'm going to try to remove this natural log. And how do I do that? I'm going to raise e to the power of each side. So what's that going to do for me? That's going to give me e to the y equals 2 arctangent x plus 3 arc sine of x plus 5. Do I want to go any further with this? I think I'm not going to. So what I'm going to do now is I'm going to differentiate both sides of this function with respect to x. So left-hand side, what's the derivative of e to the y? With respect to y, first of all, that's just as simply be e to the y. But then I have to multiply that by dy dx. So e to the y times dy dx. So now I'm going to take a derivative of each of the next terms one at a time. So I have two derivatives here that both involve inverse tangent functions. So I believe you've done both of these in other exercises. So let's develop at least one of them kind of long form, and the other one I'll kind of use a more canned shortcut. But if I want to take a derivative of, and I don't want to use, let's say u, because I've already used y. If u equals arctangent of x, don't really have a good derivative for arctangent, or maybe you do, but let's rely on some inverse trig functions here. If u equals arctangent of x, then that means that x equals the tangent of u. And now I can take a derivative of both sides with respect to x. What's the derivative of x with respect to x? The derivative of x with respect to x is 1. What's the derivative of tangent of something? That's going to be secant squared of not x, but u. And this will be multiplied by not dy dx, but du dx, which means that du dx is equal to 1 over secant squared of u, or equivalently, cosine squared of u. So what is cosine squared of u? Let's draw a triangle here. How did we get here? So we said originally that u is equal to arctangent of x, or equivalently, that x is the tangent of u. So since we're talking about the tangent of u, we can treat u like it's the measurement of an angle. So let's put that there. If tangent of u is equal to x, that means that opposite over adjacent of this triangle I'm making should be x over 1. So let's do this. Opposite side x, adjacent side 1. So what's this hypotenuse? What's the length of this hypotenuse? That I can get from Pythagorean theorem. X squared plus 1 squared equals hypotenuse squared. So x squared plus 1 squared equals question mark squared, which means that question mark is equal to the square root of x squared plus 1 squared. So I'm going to label this hypotenuse the square root of x squared plus 1. All right, so what's the point? We know that du dx is equal to cosine squared of u. What's the cosine of u here? The cosine of u, in this right triangle paradigm is adjacent over hypotenuse. So 1 over radical x squared plus 1. So if I square that, that'll be simply 1 over x squared plus 1. So long way around, but that is the derivative of arctangent of x. So e to the y times dy dx is equal to 2 times 1 over 1 plus x squared. And I'm not going to do this long form, but I encourage you to, I feel like there was another exercise where you had to take the derivative of arcsine of x, but this comes out to be 1 over radical 1 minus x squared. And then finally, what's the derivative of 5? That's a constant, so its derivative is 0. So I get now e to the y times dy dx is equal to 2 over 1 plus x squared plus 3 over radical 1 minus x squared. We're looking for the derivative, so I need to isolate dy dx. So dy dx is equal to 2 over 1 plus x squared plus 3 over radical 1 minus x squared all over e to the y. But what is y? Y was the very first thing we identified. So, or something else we can rely on is we said e to the y is equal to 2 arctangent x plus 3 arcsine x plus 5. So let's go ahead and substitute all that in for e to the y. So over 2 arctangent x plus 3 arcsine of x plus 5. So pretty involved derivative. There are probably many ways to kind of algebraically manipulate this before you get to this point, but I just showed you one. Whatever, if there are ways which make more sense to you, feel free to use them.